all our fellows, the Academy members, and most importantly to Professor Malik Maaza. This is a very important historic first presidential talk for us at the African Academy of Science, and the whole strategy around this is to actually showcase our fellows and specifically the significant research that they are doing and the impact that they are having on the African continent. Our first presenter in the presidential series will be Professor Malik Maaza, and I'm going to introduce him. And then I'm going to hand over to Professor Nkem Nkumba, who will chair this session this afternoon. And with that, let me first introduce Professor Maaza. He is a native North African and holds a PhD from the University of Paris. He is currently a South African UNESCO UNISA IT Labs NRF Africa Chair, very importantly in nanoscience and nanotechnology. He's also a joint staff of the University of South Africa and the National Research Foundation with a H-index of 107 and total citation above 35,000. Now, I'm saying this is very important because we are having extensive discussions at the moment around fellowship and the criteria to become a fellow. And this is important because it's a global discussion. I've been discussing this with other academies and also other universities. And last week in Stellenbosch, we discussed the importance of criteria for selection of fellows. And we are continually improving that. And this is very important. I want to go back to Professor Maaza, who is a fellow of various academies, including the African Academy of Science. He's a very staunch supporter of the African Academy of Science. And with today's session, I would like to invite all our fellows to actively participate and engage with the African Academy of Science. To please contact me if you are keen and interested to be involved in certain important subcommittees, or if you would like to make an important contribution. And this is exactly what Professor Maaza has been doing. And I think that's very important. He is also a member of other academies of science. And I think that shows our very important horizontal transfer of knowledge and collaboration. Professor Maaza has also been bestowed several awards and accolades, and some of these include the African Union Kwama Nkrumah Award for Excellence in Science and Technology. There's several others, such as the Galileo Galilei Award of the International Community of Commission of Optics, and the World Cultural Council Hong Kong, and then the UNESCO Salam Spirit Award. I think this is significant, this is important, and we need to recognize our fellow AAS members. He's very importantly also been the architect behind continental and national ongoing platforms, including, and very importantly, the African Laser Center, and also the African Materials Research Society and the African Light Source and Nanoscience African Network. And I think this is very important. He's setting an example. And once again, I would like to encourage all our fellows to be involved and contribute in the same spirit as Professor Maaza has to the African Academy of Science. We are looking forward to your presentation today, and I do hope the fellows will stay engaged with us, because we will announce our new tier of fellows on the 1st of April, and the next call will be announced on the 1st of April. And we do hope that the AAS will be supported, and that this day will be enjoyed, and that you all will actively participate in this event. And with that, I'm going to hand over to our chair, Professor Nkem, just to say a few words, and then we'll ask Professor Malik Maaza to start his presentation. Just a word from you, Professor Kim.
Yes. Thank you very much, Madam President Liz Coulson, for that kind introduction of Professor Malik Maaza. And thank you also. This series of lectures is your initiative under your tenure as our president. It's a new thing for the Academy, and we're very proud here at the Secretariat to support and make it come to life. We envisage that this is the first of many presidential lectures that will bring to light to both our academic community, but to the overall global world of science, the rich work that our fellows are doing. And with that, I would simply call on Professor Malik Maaza to please start with your presentation.
Honorable President, Professor Kirsten, Honorable Executive Director, Prof. Peggy Boateng, Program Director, Professor Nkan, Honorable Fellows, and Honorable members of the AAS family, and each and all protocol respected. First of all, allow me to express my gratitude to our President and the full Secretariat for these outstanding initiatives, which more or less would involve more the fellows of the AAS family and explore all together the way forward to create more synergy within the continent and respond to the vision of STISA 2063, as well as to the mission and the vision of our academy. By that, colleagues, if you allow me to start, today what I would like to do, please, I would like to share with you some of the activities that we have carried out since 2005 with a number of colleagues from both the continent and the diaspora, who helped us quite a lot to shape and cement the nano activities in a multidisciplinary way within the continent and beyond the continent also. This talk is given more or less within the framework, of course, the African Academy of Science, and I would really salute our President and the Secretariat for this visionary initiative of the President lecture series. And also it's given within the framework of the UNESCO, UNISA, Itamba Labs, NRF Africa Chair in Nanosciences and Nanotechnology, simply abbreviated as U2ACN2. This U2ACN2 is a trilateral partnership, between the UNESCO, the University of South Africa, and Itamba Labs, which is a national facility of the National Research Foundation of South Africa. And this contribution towards the SDGs is justified somehow by the fact that if we embark, each and all of us, in addressing in a way or another the SDGs, we would respond to STISA. We will start to implement and cement further the vision and the mission of STISA 2063. That is fact one. Fact two is that all of us, we are carrying out research indeed, and we are producing knowledge indeed, but we have also responding to the society, and in particular to the expectation of the society as a whole and the policymakers specifically. And in the case of water, colleagues, as you can see, these are statistics of the United Nations as well as UNECA in terms of the water availability. And this study was published in 1990. In 1990, the statistics shows clearly that the water availability within the African continent is given by the cyan bars, while in 2025, that is this year, the expectation is that nearly all the African continent will be under vulnerability threshold. And it is a fact, colleagues, it is a fact. And some of the countries will be under huge duress in terms of scarcity of water. As you can see, quite a number of countries in the dark bars shows clearly that they will be under scarcity, while the majority of them, if not the bulk of them, including North Africa, but all the sub-Sahara, will be under vulnerability. Therefore, colleagues, we have to come and to embark to cooperate together at different disciplines or at the bridge of different fields to address this water issue. The other reason for which we have to embark in R&D translations is that food security wise, the expectations by the GRFC is that the food security is a challenge for a number of continents, and specifically for Africa, as you can see. And we have, colleagues, as scientists, it is okay to produce knowledge. It is universal, normal, but we need also to put this science and these findings to the service of the community, so to ensure that the policymakers will be convinced to increase the expenditure in science and technology above the 3%. All the countries in Africa, all of them, they spend less than 1%. For the moment, the one who is nearly close to 1% is Egypt, seconded by South Africa, also nearly 0.8% of the GDP. But the rest of the African countries, they are less than 3%, less than 1%. And colleagues, as I mentioned, the UNESCO chair is a trilateral partnership between the UNESCO plus Fontenoy in Paris, the University of South Africa, UNISA, and Itamba Labs, which is a national facility of the National Research Foundation of South Africa. It happened that the UNESCO chair also has been recognized as early as 2010 by the African Union as a network of excellence, and even before getting the label of the UNESCO. And of course, it's the sole unique UNESCO chair in the South in the field of nanosciences and nanotechnology. Well, we have embarked, colleagues, as per the advice of a number of fellows, including fellows of our academy, but also members of the diaspora, who wisely advised us to embark in a multidisciplinary research. And by nature, that is the field of nano, yet indeed it's material sciences centered, but it touches on chemistry, environment, engineering, computer, physics, life sciences, agriculture, ecology, name it. And I would like to share with you, colleagues, some of the typical examples that we have achieved within the framework of a large cooperation within the continent, North Africa, East, West Africa, Southern Africa, as well as Central Africa. And colleagues, in that regard, the UNESCO chair has two nodes, one in the Gauteng region in Johannesburg at Florida Science Campus of UNISA, and the other one in the Cape region, that is at Itamba Labs, where a bulk of African fellows do each year, around 20-23 fellows, junior and seniors, do come visit us, fully sponsored by the chair. And colleagues, I would like to share with you some of the, how can I say, this a common project or common programs that we run closely with our colleagues from different parts of the continent, being it North Africa and the Sub-Sahara, and we have embarked in a number of them. But colleagues, I would initially we were stressing on SDG 4, that is quality education, with the SDG 5 in terms of gender equity, as you will see. But we thought that we have reached the critical mass since 2005 up to 2013. Upward, we have reached the critical mass, and therefore we have to embark in science with R&D translation to the society. In terms of SDG 4, colleagues, SDG 4, as you can see, These are the fellows who graduated. This is a portion of the students who have graduated from Morocco, Libya, Rwanda, Ghana, Algeria, Nigeria, Malawi, I think Zambia, South Africa, Botswana, DRC, and so on and so on. As you can see, colleagues from Burkina Faso, Uganda, we have touched on nearly on all regions of Africa. And, as you can see, 75 MSc graduated and 91 PhDs. We take them at the level of the MSc. We, how can I say, we train them jointly in the joint co-supervision with a number of colleagues, either within the continent itself or the members of the diaspora. And of course, colleagues, that is since 2013 only that I'm counting, because it's there where the UNESCO chair has started. A number of these fellows here, if not all of them, have been absorbed by the job market, some of them by the private sector or some of them by the public sector. Of course, it was not limited to PhDs and MScs, but also to postdocs and early career scientists, where indeed there is a need for such. And as you can see here, some of the fellows here are coming from different parts of the continent and beyond the African continent, such as this fellow from Yemen, from war zone countries, from Iran, from Sudan, and so on and so on, from Cote d'Ivoire, Ethiopia, Ghana, Cameroon, Madagascar, Uganda, South Africa, India, Morocco, Cameroon, and Indonesia, as well as Sudan. So colleagues, gender-wise also, as to obey by SDG 5, it happened that within the African continent, we have neglected the female gender component, and therefore we are losing 50% of our GDP. Therefore, it was decided that within the UNESCO chair, 50% of the fellows within how can I say, should be males and compensated by male fellows. And colleagues, by adopting this approach with the large and cohesive reciprocal dynamic within our African colleagues, as you can see, the citations of the publications under the affiliation of the UNESCO chair, the UNESCO Africa chair, has increased from tens, colleagues, to thousands. And this would never have been able to be achieved alone by ourselves from the South African perspective, at least in our case. But because this dynamic within the continental landscape has managed to allow us to be boosted at this level. And of course, colleagues, you would understand these citations by scientists from Asia, the Americas, Russia, and China, as well as Europe, is a reflection of the quality research which is carried out within the continent in the field of nanosciences and nanotechnology, due to this dynamic, colleagues, involving a number of African junior and senior colleagues. Of course, colleagues, what happened is that once these numbers have been reached, a number of policymakers in different parts of other countries in Africa, the policymakers have been convinced to embark in creating nano initiatives. Yes, indeed, the South African nanotechnology initiative was the first one, but it was followed by the Moroccan, the Egyptian, Tunisian, Nigerians, Kenyans, and Zimbabwe, and it is moving, it's growing quite extensively. Well, colleagues, as I have mentioned, while the previous cases that I have had to share with you speaks to SDG 4, quality education, and SDG 5, gender equity, I wish to share with you some typical examples of R&D translations embarking in addressing SDG 6, 7, 12, and 13 somehow. And you would see that, in effect, these examples that I am touching on speak also to zero hunger, that is a food security. One of the typical examples in which we have worked extensively and cohesively with a number of colleagues from Africa is to try to address this problem of skin cancer melanoma. Africa is indeed richly illuminated by the sun, and quite a number of communities do suffer from skin cancer melanoma because the DNI in Africa is very, very high, in particular in the sub-Sahara, as well specifically in the southern Africa part. And this is due to colleagues, a large DNI direct normal incidence from the sun. Yet indeed the UV is around 5%, but because the DNI is high, therefore the density of the UV is high. And it happened that while the population of those where the regions where the DNI is very high, they do suffer from skin cancer melanoma. A community in some communities in Africa do not suffer from that. Why? Because they use some specific indigenous knowledge somehow. And in particular, the case of the Khoisan community. The Khoisan community is a black community living at the, how can I say, between Namibia, Botswana, and South Africa. And this community are very well known that they do not suffer from skin cancer melanoma. So a study was done by the fellows from different, by the way, let me just share with you those who were involved here is Ntombi from South Africa, Nandipa Bota from South Africa, as well as Hamza Mahmoud from Egypt, colleagues from Iran and Pakistan, Belgium, but as well as India. And colleagues, you can see that in particular these fellows have managed to come with a potential solution whereby they have synthesized what we call cerium oxide nanoceria, which is the top of the range of the cosmetics. But they have synthesized it, colleagues, using what we call Hoodia gordoni. This Hoodia gordoni is a plant which is proper to the southern hemisphere, which is chewed by these communities, by this Khoisan black community. When they chew it, colleagues, in effect, they remove fat from their body. And that fat is, how can I say, it's the origin of removal of the fat is this, what we call P57 molecule, which is contained in this Hoodia gordoni. But also what they do, they powder this Hoodia gordoni and they mix it with the goat milk and they make a formulation and they put it on their skin. And it happened, this formulation that they use is very effective in stopping the UVA, UVB, and UVC. So what we have, what these fellows have done that I mentioned, they have borrowed this indigenous knowledge and they made nanoceria, nanoscaled cerium oxide using a natural extract of the Hoodia gordoni. And instead of mixing it with the goat milk, as the Khoisan community do, they have made a standard formulation, a scientific, technological formulation, a modern one. And what we have observed, colleagues, they have observed that this formulation of this cerium oxide synthesized by using this indigenous knowledge, it stops the UVA1, UVA2, UVB, and UVC. And as you can see, the stopping power is over very long UV blue range. It's better than all those skin protection creams that and formulation that we find in the commerce currently. So here, colleagues, better than that, what they have demonstrated that this cerium oxide not only stops the UVA and the UVB and the UVC, whereby, as you can see, colleagues, here is the reflection properties of this area. As you can see, the UV is really at the detection limit of the detector. Therefore, the UV is stopped completely. And the colleagues, what happens is that using this cream here of cerium oxide, it shows bioengineered via this indigenous knowledge of the Khoisan, the Hoodia gordoni. The ROS activity of this powder here is nearly zero, which means that it is not harmful to the DNA of the skin at all, which is not the case, colleagues, of the commercial ones. The commercial ones, if you use a large concentration, it becomes harmful, which is not the case for the one that has been synthesized using the Houdia-Gordoni knowledge borrowed from the indigenous knowledge from the Khoisan community. And colleagues, the message to take from here is that we as a scientific community from different parts of the continent, we came together, as well as from the global south in particular, or in general, we have managed to valorize and prove scientifically that indigenous knowledge by the Khoisan community is indeed valid and has a scientific proof and factual indeed. Colleagues, I would like to share with you another typical example of the indigenous knowledge by the Himba community. The Himba community is a Black community who lives in the south of Angola and the north of Namibia. And these fellows, this community, do not shower the way that we shower. They do not use water. Their water is scarce. So what they do, how can I say, they use a red ochre. It's a rock. They know what type of rock they have to take, and they take this rock, colleagues, they take this rock and they powder it in a form of minute, very fine powder, and they mix it with the goat milk, and they put it, how can I say, they put it all over the body, all different parts of their body, including their hairs. And it happens, colleagues, this community does not suffer from any bacterial infection. And colleagues, you do understand the Staphylococcus aureus has to be, but it happens that these fellows are adamantly very how can I say, they are protected against this. And well, we have requested these fellows from Botswana, from Sudan, from South Africa, and from Iran as well as Iran. These are modeling fellows. This is a student, is a postdoc and an early career scientist, and they work together, and they went to scan the data, to do data mining and the literature survey, and they have found out that yes, indeed, this community do use this powder, and it happened that this powder that they were using, it's iron oxide, and this iron oxide, it's a lamella, it's a nanoscaled material. And as you can see here, colleagues, the bar, it's a nanoscaled. And colleagues, when they put it on their skin, in effect, colleagues, when they put it in their skin, this red ochre, it stops the UV and the blue radiations, not 100%, but above 95%, colleagues, that it protects them from the skin cancer, melanoma. In addition, that colleagues, that red ochre on their skin reflects heat back, and therefore it protects their skin from a burn, colleagues. Better than that, colleagues, is that red ochre, in effect, it is extremely very effective against the Staphylococcus aureus and the E. coli. And as you can see, colleagues, the brown one is the response of this red ochre against these two bacteria. And you do understand, colleagues, that yet indeed it's not as high as the streptomycin, which is the modern pharmaceutical antibacterial, but colleagues, you do understand that it is still active. Not as much as this one, but it is active. The streptomycin is $100 tube, and the red ochre is a cent or nearly $0. But somehow, colleagues, the message to be taken home is that here we have also once again validated an indigenous knowledge, a knowledge by how can I say, derived from our grandmothers and grandfathers and the elders. What we have done here, we have given once again a scientific validation, a scientific factual parameters stating clearly this indigenous knowledge it has a base. And in addition to that, colleagues, it allowed us as a scientist to publish in one of the top journals, family journals, that is Nature Scientific Report, for the students, in effect. The third example that I would like to share with you, colleagues, while the previous ones, they were related to health, the second one that I would like to share with you, colleagues, is related to hunger, food security. Colleagues, all of us, we do suffer when we go to buy food from the supermarket. We have noticed that the food prices have gone up, they shooted up quite high. Why is that reason? In particular in South Africa or all over the African continent and the world. Why? Because the price of fertilizers has rocketed. And it has rocketed because mainly Russia and Ukraine are the major fertilizers suppliers. Because the war zone in this region here, so the prices are fluctuating because the supply has been affected. Therefore, it was necessary to find a way to produce nanofertilizers locally and to test their efficiency. So for research, we have involved postgrad students and postdocs with an agri background, that is Gabriel Kaningini from DRC, Tobo Motlamani from Motlame from Botswana, as well as a chemist and physicist from Egypt and from Botswana, from South Africa. And it happened, colleagues, the fertilizers that we have embarked in are not the organic fertilizers. They are these ones are a little bit complex, but what we have done, we have chosen rather chemical fertilizers, which are fertilizers for the plant and not for a nutrient for the soil. And the colleagues, what happened is that we embarked in this because there's figure here from the GRFC stating that sooner or later, by 2050, Africa will be under huge duress in terms of food security. And colleagues, you do understand that we needed to tackle it. And science has to come in, not only in terms of knowledge generation, but R&D translations. And here, these fellows, colleagues, what they have done, I will jump this, colleagues, I will jump a number of slides, but the copy will be with the program director and with the AAS secretariat. They may share with you, share it with you if you wish. What is sure, colleagues, the four fellows that I have mentioned from Botswana, from DRC, Egypt, and South Africa have managed to synthesize calcium carbonate, and calcium carbonate or iron carbonate are very well established as fertilizers. And the colleagues, as you can see, these are nano fertilizers, which means that you don't need a kilogram of a fertilizer for a hectare, but you would need some 10 grams because they are nano. Because the surface to volume of a huge, you don't need a huge amount of nano fertilizers, a small amount relatively to the micron size fertilizers. And colleagues, they have tested them on tomatoes. Here is the plant of tomatoes without fertilizer, with a small amount, with an average amount, and with a larger amount. And of course, it was duplicated in different parts of the world: China, New Zealand, Australia, Ghana, Kenya, Ethiopia, Morocco, Algeria, and other countries in Europe and Canada. Colleagues, this is the tomato without a fertilizer. This is with a small amount of fertilizer. This is with an average, and this is with a large amount of, but less than the threshold of toxicity. And as you can see, colleagues, the nutrient value of these tomatoes are the same, but the size are different. You can see, colleagues. And again, colleagues, it shows clearly that we have to embark and duplicate these findings in different parts of the continent. And we have hopefully we have applied at the continental level for a Belmont Forum funding. If it is successful, we will be able to duplicate this know-how all over the continent. Within Ethiopia, within the east of Africa, West Africa, that would be Ghana, north of Africa, that would be Morocco and Egypt, and the southern Africa would be South Africa and Zimbabwe. Colleagues, when it comes to the water, you have seen that this graph, colleagues, we have to ensure that the water that we are using should be treated. Water treatment should be massively implemented, and therefore, specifically the water that is used when we shower, or in the agri sector, that is water which contaminated with pesticides. And colleagues, in that regard, we need to how can I say, to have experimentalists as well as computational engineers, as you can see, from Iran, from Egypt, from Botswana, and Senegal, as you can see here, colleagues. And these fellows have managed to come with a material which is, I will not go through the scientific detail, colleagues. What is sure is the titanium dioxide is used in our, how can I say, is used extensively in different fields, but it happened that this TiO2 is an excellent photocatalyst, which means that if you put the titanium dioxide in a contaminated water and shine it with the UV, it will decompose the germs, it will decompose the pharmaceuticals, contaminant, the pesticides, and so on. But unfortunately, to make this TiO2, the standard TiO2, active, you are obliged to use the UV. And the UV lamps are expensive. That technology is expensive. Therefore, we have to come with a cost-effective way that would allow us in Africa to have more or less the same response, the same efficiency in retreating water, which means decomposing the pesticides in the agri sector, decomposing the pharmaceuticals, and how can I say, contaminant bacteria in flash water, and so on. And it happened that these fellows of us, the four fellows here, they have managed to come with a computational and to come with an experimental material which allows us to have this specific powder, which is nanometric, very effective, colleagues, in terms of decomposing the dyes. Here is a methylene blue. If you have water contaminated with the methylene blue, if you decompose that methylene blue, you will be able to decompose nearly all pesticides in the, how can I say, in contaminated water in the agri sector, as well as bacteria in the flash water, and so on. And as you can see, colleagues, this tube contains water which is contaminated with the methylene blue. And here, colleagues, is the same water within which we have included that black powder of TiO2, colleagues. After 30 minutes, as you can see, colleagues, it became a little bit less blue, which means that the black powder of TiO2 has severely decomposed the methylene blue and made it, after 2 hours nearly, the methylene blue is completely decomposed, which means that water is safer to be clean or to be reused so far in the agri sector and the cleaning the stuff. So, colleagues, this was a technology somehow whereby Senegalese team, Egyptian team, South African team, and Botswana team came, as well as with the Iranian team, came all together to more or less deal with this problem. Here in this case, colleagues, also I would like to share with you this in terms of clean energy in particular, colleagues. As you are aware that there is an exodus of the rural area towards the how can I say, the urban areas, looking for jobs and job opportunities. And therefore, colleagues, the architecture in the urban areas will be mainly dominated by large, very tall buildings and not the small houses. No, it's mainly tall buildings. And in these tall buildings, colleagues, within the increase of temperature worldwide, globally, due to the global climate change, you would understand, colleagues, all of them will be using air conditioners, colleagues, to cool down the inside of the flats and the rooms and so on. And colleagues, for the moment, the number of air conditioner worldwide is around 1.6 billion unit. But by 2050, colleagues, it is expected that the number of air conditioner will reach 5.6 billion unit, colleagues. This is massive, an increase from 1.6 to 5.6. This is massive, colleagues. And the energy to be used to operate this 5.6 billion unit, colleagues, is the energy which is used currently by the USA, by China, by Japan, by Europe. You do understand, colleagues, it is impossible. It is impossible to use such a huge amount of energy just to operate air conditioners to cool down flats and cars and so on. And therefore, it is necessary to come with a smart technology which would be less intensive in terms of fuel consumption and energy consumption in general. For such a colleagues, you would see that this is a thermograph, which means we measure the temperature from gradient within a house and within a car. As you can see, colleagues, the major heat exchange is through the glass windows. And therefore, both in a housing, a normal one, or a car. Therefore, it is necessary to coat this glass, being in a house window or a car window, with an intelligent coating. This intelligent coating, colleagues, should stop the heat from the sun when it's hot, and should allow the heat to come in when it is cold outside. Therefore, we have to paint the glass with a smart coating to make this window stopping the heat when it's hot, allowing the heat to come in when it's cold. And this material is called thermochromic material. And therefore, if it is the case, the window will become smart, because you would not need to implement or to inject any energy to make it flipping, blocking the heat when it's hot and allowing transparent to heat when it's cold. And this, colleagues, I will not go through the details, the science of it. The science of it is a really a Nobel Prize type science. That is a mode transition, that is good enough phenomena, and so on. This is driven mainly by fellow from Botswana, Sudan, Cameroon, Senegal, and Malawi in the past, and South Africa. So you colleagues, you see that the fellows, the young fellows who were involved here are here, but the other senior fellows were also working in this field, colleagues, and have managed to come with a smart window. Here, colleagues, it's a toy house, one with the windows, one non-covered with this smart paint, and the other one covered by this smart paint, colleagues. What happens is that you shine them with a lamp at a certain distance, and this lamp is equivalent of 1.5 sun, which means the glass here is receiving a heat as if it was shined by a sun which is 1.5 brighter than the normal sun. As you can see, colleagues, the coating, the window which without the coating, the thermometer inside, it measures around 42 degrees Celsius. While the one with that smart painting, colleagues, the thermometer inside, it measures around 33 degrees Celsius. Is nearly 10 degrees difference, colleagues, and therefore it is a truly very effective as a green air conditioner. And you can see, colleagues, that it happened that this material, quite a number of countries have a large deposits of vanadium minerals within Africa. So it's a mineral beneficiation for the African continent as a whole, and South Africa especially, because it has the very large deposits, approved deposits. But nonetheless, colleagues, here it's a field where the youngsters have came in and shown effectiveness from Sudan, Botswana, Cameroon, Senegal, and Malawi, and others. And colleagues, in fact, this intelligent material came from the fact it has the same properties as this animal here, what we call a Gemsbok, the oryx. It's the logo of Qatar Airways. This animal is capable not to drink water for days, for hours, for days, for weeks, for months. Why? Because colleagues, its skin, it stops the heat when it's hot. When it's cold, it allows heat to come in, and that's exactly what we have biomimicry copied, and these fellows have copied. Colleagues, I would not go through the physics of it. It is not the point. The point is that we have operated as how can I say, as a together team from different parts of the continent and beyond, and we have involved both youngsters at the MSc, PhD, and a postdoc level, as well as the senior colleagues using highly advanced technologies to come with this smart coating, colleagues. Again, for those who are expert in the field, they just could rely the temperature here to this behavior of the optical transmission that I will not go and discuss. You would understand, colleagues, instead of using this, how can I say, this standard air conditioning system, it is wise to use to coat the windows of these flats by this smart material. First of all, this smart material does not consume energy, which is not the case, colleagues, of the air conditioner, and therefore there is no CO2 footprint, zero CO2 footprint, colleagues. And it's in high tech, colleagues. It can be applied both in buildings as well as in the car industry. Colleagues, I will jump this case because time limitation. Yet, how can I say, colleagues, I would have loved to share with you this because it involves a fellow from South Africa, from Morocco, from South Africa, and from Iran. But I would not speak about it. You will have, for those who would be interested by it, please, you may reach me. I will explain to you, and I will be delighted to share with you whatever is related to this. I have to jump to the last example, colleagues. The last example is related to climate action. Colleagues, in this, again, here are fellows from the DRC, from Botswana, from Egypt, from South Africa, and from Senegal. Colleagues, you would understand that this is the footprint of carbon emission per capita. I would like to stress on the fact that this graph reports the carbon amount emission per person per year, colleagues. This, what does it mean? And you would see, colleagues, that China is not the largest emitter. No, at all. South Africa emits more than China, as you can see. China is 7.1 metric tons per year per person, and South Africa is 7.4 metric tons per year per person. The rest, colleagues, what does it mean? That means within the from the South African perspective, we have to deal with the CO2 problem. But as you can see, colleagues, colleagues, Africa has a low footprint, 0.7. But colleagues, if we could come with a solution a green solution to minimize the CO2 footprint, we could, from the African perspective, we could knock on the CO2 market, which would be coming in 2028. But nonetheless, South Africa is not the unique culprit here, colleagues, but Egypt, Algeria, Nigeria, and Angola, as you can see, as well as Libya, including also Morocco, as a major emitters. Therefore, colleagues, we have to come all together with a potential solution. And in that, with this idea in the spirit, fellows that I have mentioned came with the potential way of decarbonization. As you are aware, decarbonization process are mainly three: CO2 sequestration in mines or under the sea, and the CO2 cycling, or the CO2 conversion. In the CO2 conversion, there are three major ways: either with the physical technologies, which are not cost effective, or the CO2 conversion by chemical chem-eng that is highly energy intensive, or biomimic Mother Nature and do bio-inspired conversion. And it is this one that these three fellows here, or four fellows or five fellows, have managed to do. And what they have done, they converted CO2, colleagues, to this whitish powder. And it happened, this whitish powder is a carbonate, colleagues. And the carbonate has quite a large applications in the field of agriculture as a fertilizer, what I have shared with you before, as a supplementary compound in the cement industry, as well as a filling material in dentistry, as well as a powder component for a drug delivery. So you would see, colleagues, these five fellows have managed to come with an outstanding solution which has application in this strategic field of cement industry, agriculture sector, pharmaceutical, and dentistry, colleagues. And by doing such, colleagues, the examples that I have shared with you, if you allow me just to summarize, is that we have, how can I say, embarked in nanofertilizers with addressing SDG 2. We have validated an indigenous knowledge that is in relation to for pharmaceutical application, in particular skin cancer protection, that is in relation to SDG 3. And then we have showed the colleagues that we embarked in human capital development, both at the postgrad level as well as early career scientists. So therefore, quality education. We have noticed the colleagues in all the projects that we have embarked in, we have observed, strictly speaking, the gender equity, and we have also shared with you using black TiO2 as a mean to decontaminate water in a very cost-effective way that can be duplicated in all parts of Africa, specifically in Egypt and West Africa. Why? Because in both regions they use the zobo drink and the hibiscus sabdarifa, they call it bisap in Senegal, the zobo drink in Nigeria, and al karkade in Egypt. So how can I say, the phytocompounds from these plants are very effective to bioengineer this material. And also we have embarked, colleagues, in terms of affordable SDG 7, affordable and clean energy, as well as SDG 11 in terms of sustainable cities, that is green air conditioning. And also, colleagues, we have shared with you the case of climate actions, that is converting CO2 to a product which is multifunctional. It can be used in multi-sectors. And colleagues, by doing that type of approach, by adopting this continental dynamic in this, I can say, while we were producing knowledge, where we were embarking in knowledge production, that has not stopped us to, how can I say, to be highly cited. As you can see, the previous one that I have showed you at the beginning, it was stopping at 23, but 24, we went above 5,000 citations, colleagues, from by, how can I say, from publications under the affiliation of the UNESCO chair, involving that dynamic, that continental dynamic, involving young fellows, early career scientists, as well as senior scientists. And colleague, this is the advantage in working at that continental dynamic, at the continental landscape. And colleagues, that does not stop us here with it. Is not the end of it. We have had, sorry, I think colleagues, yes, colleagues, quality-wise, you do understand that among that citation that I have mentioned, it has allowed us as African scientists with the minute amount of R&D infrastructure and so on to be able to generate high quality data that are published in Nature family journals, as you can see, colleagues. And of course, these have been recognized, as our Honorable President, Prof. Korsten, has mentioned. It has been acknowledged by a number of international awards, as well as in national accolades. Here, example, colleagues, here, colleagues, the case of receiving on behalf of the UNESCO chair one of the orders of given awarded by the President of the Republic of South Africa, Honorable Cyril Ramaphosa, which is the Mapungubwe Order. That is not a personal achievement, it is a continental achievement by say colleagues. And as I have mentioned at the beginning, colleagues, our vision within the UNESCO chair, and thanks to these colleagues from the diaspora, as well as those who helped us within the continent, we moved from level 1, which is purely human capital development and knowledge production, to human capital mobility, level 2, whereby early career scientists and senior scientists are involved, to embark in entrepreneurship at the level 3, and hopefully level 4, whereby we'll be able to respond to the expectation of the society. And in that regard, colleagues, the fellows, being it from South Africa or from Africa or any part of or beyond, they are obliged not only to ensure they acquire knowledge and expertise, both scientific and technical, but also to be able to generate prototype, laboratory prototype, and therefore at the end of their thesis they must be at the technology readiness level 4, and for some to embark in patenting. As you can see here, fellows from Touria Khamlish, originally from Morocco, as well as here a number of fellows from Morocco and South Africa. And as I mentioned, colleagues, the idea is to duplicate this dynamic here, this program within the UNESCO chair in different parts of the continent and through a number of national initiatives. And colleagues, those fellows who have been trained, they went back their home and they have created, they joined the number of number of centers and the number of institutions whereby, how can I say, whereby they have created the nano activities in their home countries, while keeping still this dynamic within both regional and south-north and north-south within the African continent. And colleagues, by that, I would just to express my gratitude to each and all of you and to all our funders and sponsors within the year since 2005, specifically following the implementation of the UNESCO chair in 2013. And I wish to just to how can I say, end by 3 quotes, one from the late Nelson Mandela, which says, it always seems impossible until it's done. We never thought we will be able to be at this level. We never thought that we will be highly cited more than 100 times. We never thought that we will be able to publish in Nature Scientific Journal Family. We never thought that we will be able to patent, and we will never be thought that we will be able to generate multi-skilled, highly skilled workforce of tomorrow. And also, colleagues, late Jomo Kenyatta has said that our children may learn about the heroes of the past. Our task, you as fellows of the AAS, our task is to make ourselves architect of the future. And the last one, colleagues, if you may say, this is a really close to my heart also. Late Kwame Nkrumah said, je suis africain, non pas parce que je suis né en Afrique, mais parce que l'Afrique est née en moi. I am not an African, not because I am an African, not because I was born in Africa, but because Africa was born in me. And I thank you, colleagues, and thank you, Program Director, and thank you, colleagues, for taking off your time.
That was fantastic.
Thank you, Prof. Thank you.
Madam President, should I? Madam President, you want to continue or should I?
Yes, I would just like to start. Thank you very much to Professor Maaza. This was incredibly inspirational, and for our first presidential lecture, I think it set the tone, and we are looking forward to our next round of presentations. And I just want to personally say to Professor Maaza, thank you for your support. And thank you leading by example, and thank you for presenting this incredible life work. This is the spirit of the AAS, and I want to just acknowledge your excellence and hard work in the continent.
Thank you so much.
Thank you very much, Madam President Liz Corson. And to our audience who are still online, we had programmed a few minutes for questions. We know that we've gone a little bit longer than previewed, but we'll have, I hope Professor Malik Maaza would have a few more minutes for some questions from our audience, if they will.
Yes, please.
Please indicate by a show of hand, and our IT person would have you have a microphone, turn you on.
There's 2 hands already.
Okay, if I can see them here, I'm sorry. Okay, my machine is together.
If you can see me, but hello, everybody.
Hello, Prof.
Good afternoon, and greetings from UNESCO. I would like to take this opportunity to thank Professor Malik Maaza for your inspirational work, especially as we talk about science diplomacy and how your work has, affected this journey so far. I thank you very much for the presidential lecture, from all the, SDGs. And we're doing this work not alone, but with many people in Africa, particularly mid-career researchers. So I'd like to thank you very much. People online are asking for this to be shared. So hopefully we'll be able to share with others. So thank you very much.
Thanks a lot, Prof. Thank you.
Thank you, Madam Edie Pegioti Boateng. To our audience, we've already answered online on the chat that we will upload this live presentation on our website in the very near future as we get it ready.
There's some hands.
So,
Mr. Chair.
Always come to our website for any information and all information concerning both the AAS, our activities, and this lecture series in particular. Would there be any other question? Nick, are you checking?
Yes, there is Professor Abegas. Please proceed. Yes, good afternoon. My name is Berhanu Abagaz. I would like to begin by really expressing my appreciation to our president for beginning this very insightful series of lectures. And she couldn't have chosen anyone better when we hear Professor Maaza. I know Professor Maaza when I was at AAS. We have done a lot of things together. He was inspirational. And I think personally, I feel that he has set the standard, the bar so high, I don't think any of us will ever reach to that level. And that's just to appreciate how great I feel about the lecture. I have a few comments and questions. Before I do that, can you hear me, sir?
Yes.
We hear you, Prof.
All right, good. So a few questions. The first one is a lot of the information you mentioned appears to originate from IKS, from certain communities. And from the value that you project, it seems that some benefit should be forthcoming. And have you thought about what may have to be done for the owners of the indigenous knowledge? That is question number one. Question number two, I'll be very quick. I have seen for the water purification, you gave the example of methylene blue, and all we can see from the lecture is that the color has disappeared. You mentioned that it is decomposing. Yes, its integrity must have changed. But I was wondering if you've made any tests regarding if it has not converted to something worse than methylene blue. Let me stop here, but again, with huge appreciation to the people I mentioned. Thank you so much.
Prof. Nkam,
Yes,
can
Prof.
I
Maaza. Yes, Prof. Maaza.
Thank you. Thanks a lot. Thank you so much, Prof. Berhanu. It is because of scientists of your caliber, because the role models of your caliber, that we have more or less reached this kind of level. I wish to express my deepest gratitude to you, President Berhanu Abegaz. You are a president, it's for life. Such a title. And I wish to express my gratitude to you specifically, as well as to Prof. Gurib Fakim, for the simple reason is that it is you and her who guided us more or less towards phytocompounds. Responding to your first question, indigenous knowledge. Yes, Prof. In effect, what we do is that our condition, when we, how can I say, when we approach when we approached the cosmetical companies, we have mentioned to them that the condition number one is to ensure that whatever royalties are generated, the community should benefit from it. And in that agreement, that type of commitment has to appear clearly. And it was completely at the beginning of the agreement or the memorandum of understanding. You are absolutely right. The second aspect, if whenever we do presentation, we always, how can I say, market these communities and inform the global community about them. We definitely market them correctly. When it comes to the second point, Prof, the methylene blue, you are absolutely right. You are absolutely right, Prof. In effect, yet it is still in a patenting phase, but nonetheless, what we have observed, Prof, is that this methylene blue decomposes completely, not in a harmful way. And we have also done more or less the same thing for the rand orange, the orange methylene, as well as the red Congo. And it happened that, Prof, this material is really effective in that regard. It decomposes the methylene blue. It decomposes, and there are no harmful compounds as a waste. And I would just to repeat myself, Prof. Thank you so much for asking such a question. This black TiO2 has been synthesized using natural extracts of Hibiscus subdarifa. It is some phytocompounds from the Hibiscus subdarifa which allows us to create defects in this TiO2, which makes it black and therefore very effective in decomposing methylene blue. I will be delighted, Prof, to change with you on this matter, and I'm glad to hear from you, Prof, but I hope that I responded to your questions.
Sure. Thank you. This is Nkem Kumba again. Just if I may, a similar question is in the chat room from Professor Vincent Titanji from Cameroon, I know well. He asked a question, what is being done to protect the indigenous knowledge of the concerned communities? I think you've answered that along the way by indicating that in contractual arrangements with potential commercializers, you do include a clause that the communities must benefit from it, if I'm right.
Correct.
Okay, so then we'll go to the next question. There's a hand up from Professor Ahmed El Say, if I pronounce it correctly. Can you unmute yourself, please, and ask a brief question?
Well, thank you very much. First of all, I'd just like to say that was a very inspiring lecture. And I think Prof. Maaza has indirectly, I'm Professor Ahmed El Sayed from Sudan. I'm a cardiothoracic surgeon and director of our research institute, our university research institute. So no, I just wanted to say that Prof. Maaza has indirectly answered my question. My question was, how are they proceeding along the technology readiness level? I think in his answer to the previous question, he's answered that they're doing, because this is what we need in Africa. We need to go up that TR level to commercialize whatever we have, so that it has an impact, and indirectly it will finance further research. I take my hat off again to what is really excellent and inspirational work. Thank you very much, Mr. Chair.
Thank you, Professor Ahmed El Sayed. Please pardon me if I didn't pronounce your name right. That seems to be the only hand that's left up. No, one more. Professor Agbaje Latif.
Okay, thank you. Good afternoon.
Good afternoon, sir.
Okay. First and foremost, I want to thank African Academy of Science for putting up this program. And I want to thank Professor Malik Maaza. He has made an incredible contribution to knowledge in the area of nanoscience in Africa. I'm particularly thrilled about things that have been drawn from indigenous knowledge. I'm from Nigeria, and in my university, we have a nanotechnology research group, which has been on for about a decade now. And I can see from what he has been able to deliver today, I can see a lot of things that we can tap into, leveraging on the indigenous knowledge of our people. My appeal to Professor Maaza is about a collaboration. We still, for us here, we are still developing concepts in the area of this nanotechnology. So we will be very, very happy if we have a means of collaborating with him. Thank you so much.
Thank you, Prof. Latif. We welcome you. We will be delighted to invite you to visit us for 3 months. We will cover all the costs related to it. So
thank you so much.
Work with us. We work with us, and we will advise as best as possible.
Okay, thank you, Prof. I'll get across to you.
Thank you.
Wonderful. And Professor Latif, we will make his email address available to you after this conversation. As a matter of fact, on the website, when we upload his live recording of this presentation, we will make his contact information available under that link for all who might want to contact him for any further conversations. I'm not sure you'll be able to sponsor 100 people who are on this call, but it's
And
just to at least avail. So we'll make that available. Bear with us. It's 4:15 p.m. here in Nairobi. We'll take one last call and invite you to stay in touch with us. Visit our website very often. The current leadership of the Academy is working hard to bring to you, the academic community, very rich conversations and programs that will bring out the best of what we have to offer the world. Stay in touch with us. So this last one will be Professor, I'm not sure it's Professor or not, but Gilles Kwasi. Gilles Kwasi, your hand is up. You are muted. Please unmute yourself, Gilles Kwasi.
You hear me now?
Yes, please be.
Okay. Yeah, I would like to thank you and thank Professor Maaza for the wonderful presentation. I've been involved in nanotechnology for the last 21 years in the US. And recently I moved to Côte d'Ivoire. I was like, there's no platform here to be active in the field in which I've been active for the last 20 years. And when I got the link and getting in touch with Professor Maaza, I was dreaming, and my dream came true, because what I saw is kind of exciting. The presentation the professor gave was like, yes, so a lot of things can be done in Africa, and the platform I was looking for is now available. Thank you for you all who made this possible, and thank you for the excellent work done by Professor Maaza. One small question I have for Professor is about the methylene blue. Methylene blue is an oxidation indicator. So depending on the medium, if it is an acidic medium, from acidic to a basic medium may change color. Did he test in the range of pH to see that the color change is not related to change in pH? That's one question I have. The second question is about titanium oxide. I did some work at Penn State, at the Pennsylvania State University on titanium oxide, and at some point I experienced a lot of agglomeration of particles. I was trying to do some coating, biocoating to separate the particle, but it was harsh. Did he experience something similar? Is there anything I can share from his experience there that could be helpful again for me? That was my question. Thank you very much, Professor.
Thank you. Thanks a lot, Prof. Kwasi. First of all, when it comes to the methylene blue, yes, it was not a pH. Yes, you are right to point out to that aspect, but it was not. So it's a full decomposition indeed.
Thank you so much. Thank you, Professor.
The second one, Prof. Kwasi, I have not got it correctly, but how can I say, we can exchange, and I mean we can exchange by email, and I will
Yes,
as much as possible to your second question.
thank you so much. Thank you. Thank
Yes.
you. I appreciate.
Okay. Thank you all. Madam President, should I close? I think you're gone. You still here? Okay. Well, thank you. Thank you very much again, Professor Maaza. You can tell the receptivity from our community. We've had over 110 subscriptions to this conversation, the first in a series. We would again load your talk up on our website. We want to thank the leadership of the AAS for working with us at the Secretariat to bring this series of presidential lectures to its community, to the AAS community. We invite the whole community to visit our website very soon, see all the things that we're trying to bring out. And the next lecture will be announced sometime on our website, and you receive it in your email boxes as we do publicity about it. Thank you again very much, Professor Maaza. And with this, we will bring this to a close. Thank you.
Thanks a lot. Thank you. And thank you, colleagues, for taking off your precious time. Thank you. Bye-bye.
Bye-bye. Nick?
Yes, I'm now exiting the call.
Yes.